states that rate of change of momentum is proportional to force. Rate of change of momentum is proportional to force. Is proportional to applied force. To force is the statement. So when you take a body m, you are applying the force. Initial velocity is u, final velocity is v in a time t seconds. It is getting accelerated when you are applying the force. What he says is force proportional to change in momentum. Final momentum means mass into velocity. Momentum means mass into velocity. mv minus mu by time taken is t. So f is proportional to m into v minus u by t. V minus u by t. What is v minus u by t? That is acceleration. V minus u by rate of change of velocity, that is called acceleration. Therefore, f is proportional to ma. F is equal to kma. F is equal to kma. K is constant. From experiments, EAPCET means experiments. From experiments, K is made as 1. Directly write K is equal to 1. Don't worry about that. F is equal to ma. This is the way you derive F is equal to ma, or one more method, F is proportional delta P by delta T. P is momentum. You can write like that also. But this is very rarely coming, this question. F is equal to ma. Previous years, before 18 or 17, they used to ask this one. But nowadays they are asking on questions on friction many. Friction questions are many. So that I already completed. So loss of motion is over. Now I am going to system of particles and rotational motion. 1 3 marks question is there. See, system of particles and rotational motion. System of particles and rotational motion. This is a one, I don't know, new method is what. I think 1 3 marks question will come in this. One short question will come. First I am doing one easy derivations. Define angular velocity. Derive v is equal to r omega. Derive v is equal to r omega. R is radius. Derive v is equal to r omega. Define angular velocity. So in circular motion, I am drawing circular motion. This is circular motion. So if you take some arc length, this is delta theta. This is nothing but radius. This is arc length A to B, nothing but equal delta S here. This is called angular displacement. Angular velocity I will define. Angular velocity omega. The rate of angular displacement, the rate of change of angular displacement. What is angular velocity? Rate of change of angular displacement is called angular velocity. Definition carries 1 mark. The rate of change of angular displacement is called angular velocity. This is given by letter omega. This is called omega. So omega formula is what? Delta theta by delta t. This is occurring in a time delta t seconds. Omega is nothing but delta theta by delta t. SI unit is radian by second. RAD means radian by second. SI unit is radians per second. This carries 1 mark. Derive v is equal to r omega. To derive v is equal to r omega, what is v? Linear velocity. What is r? Radius. What is omega? Angular velocity. Linear velocity already you know in kinematics, rate of displacement. So from the diagram, this is center of circle. From diagram, mathematics definition you take. Mathematics definition. So what is mathematics definition? Delta theta is nothing but delta S by R. This is mathematics. Angular displacement is equal to arc length by radius. Delta theta is equal to delta S by R from the diagram. So it says that delta S is nothing but R delta theta. Delta S linear. What is delta S? Linear displacement. Delta S is nothing but linear displacement. Delta theta is called angular displacement. Divide by delta T. Divide by delta T both the sides. Delta S by delta T. R into delta theta by delta T. Delta S by, I am dividing by delta T both the sides. Delta S by delta T is equal to R delta theta by delta T. By definition, linear velocity, by definition, V is equal to delta S by delta T or ds by dt. V ds by dt. Already omega delta theta by delta T you know already. V equal to D. Therefore, V will become equal to R omega. V will become equal to R omega. So I'll at a time I'll show you this derivation for you by moving your hand. పోయింది క్వశ్చన్ పోయింది పర్లేదు ఎట్లుంది ఇది కాదు ఇంకో క్వశ్చన్ కాదు నెక్స్ట్ క్వశ్చన్ రాశాను ఇది కాదు నెక్స్ట్ క్వశ్చన్ డెరైవ్ వీధి కూడా ఆరోగ్యం అంటారు సిస్టమ్ ఆఫ్ పార్టికల్స్ రొటేషనల్ మోషన్ హెడింగ్ పెట్టాను అది ఆ చాప్టర్ ఎక్కడ ఉంది ఇది కాదు అయిపోయింది పోయింది క్వశ్చన్ చెప్పేసినట్టేగా దాంట్లో ఉంది ఎక్కడ దీంట్లో లేదా ఇది కాదు దీంట్లో అది రికార్డ్ అయిందా డెరైవ్ ఇది కూడా ఆరోగ్యంగా
మళ్ళీ
టైం పడుతుంది మరి క్వశ్చన్స్ తక్కువైపోతాయి కూడా ఉంటే నేను చెప్పను కాదు వాళ్ళకి అర్థమైందంటే అది ఎట్లా పోయింది నాకే తెలియదు నీకు చెప్పేస్తాను ఒక హ్యాండ్ పెట్టి చూద్దాం ఉంది కదా ఇంకేం ఓకే ఓకే నెక్స్ట్ ఓకే నెక్స్ట్ క్వశ్చన్ define angular acceleration, define angular acceleration, define angular acceleration, derive torque is equal to, derive torque means rotational force is equal to I alpha, derive torque is equal to I alpha, define angular acceleration, derive torque is equal to I alpha. Answer: angular acceleration, I am defining angular acceleration alpha. What is angular acceleration? Rate of change of angular velocity is called the rate of change of angular velocity. Rate of change of angular velocity is called angular acceleration. Is called angular acceleration. Alpha formula I am giving delta omega by delta t. Omega 2 minus omega 1 by t. Alpha formula is delta omega by delta t. SI unit is radian by second square. Alpha is a vector also. What is angular acceleration definition? This carries one mark. Rate of change of angular velocity is called angular acceleration alpha. Delta omega by delta t. That means omega 2 minus omega 1 by t2 minus t1. SI unit is radian by second square. So we are deriving torque is equal to I alpha. Torque is equal to I alpha. To derive torque is equal to I alpha. To derive torque is equal to I alpha. To derive torque is equal to I alpha. So how torque is defined? Torque means rotational force. That means example, turning the door, opening the door, closing the door, opening the lock with the help of key, this all comes under torque. So torque, you are turning effect of the force. Torque is nothing but turning effect of the force. What is I? Moment of inertia. Alpha is called angular acceleration. So answer. Torque is also defined as torque is nothing but rate of change of angular momentum. This is easiest derivation. Nothing but rate of change of angular momentum. Rate of change of angular momentum. Angular momentum. Torque is nothing but rate of change of angular momentum. Rate of change of angular momentum. So torque I am writing here delta L by delta T. Delta L by delta T. Or dl by dt you can write as dl by dt you write. dl by dt. What is L? L is not length here. L is angular momentum. L is nothing but angular momentum. Angular momentum is defined as I into omega student. What is I? Where I is moment of inertia. That will come in rotatory motion just like mass. Just like mass in straight line motion, I is mr square. I is mr square. Where I is moment of inertia. Where I is moment of inertia. Moment of inertia. Omega already you know angular velocity. So L is I omega. This is first expression. L is I omega second expression. This is second expression. I am differentiating now. Torque is nothing but d by dt of I omega. D by dt of I omega. Now I constant. I am writing d omega by dt. I taken out constant d omega by dt. So what is d omega by dt? By definition, instantaneous velocity. By definition, DEF definition, d omega by dt, instantaneous angular acceleration alpha. Therefore, torque is equal to I alpha. My dear students, you see leisurely the notes. You can have recorded. You can see this. So any letter is there, you can keep message, either writing or subject. We are doing the classes, those who are hearing regularly. We are not going just next class also you can ask. So you can keep message open. So that you are satisfied. That is very, very important for us. So torque is equal to I alpha, the derivation we did. Next, students. Next question. I am telling you, next question is distinguish center of mass and center of gravity. This is very important theoretical question. Distinguish center of mass and center of gravity. Center of mass and center of gravity. Distinguish center of mass and center of gravity. You can write separate points or tabular form. Anyway, that is up to you. Separate points, you can't link properly, means center of mass, separate points you write. Center of gravity, separate points you write. Then they will see to that what differences you are written. But I am writing as tabular form, right? Tabular form, center of mass, center of gravity. One second. Center of mass and center of gravity. Writing. This is center of mass. This side, center of gravity. Center of. What is the basic difference is? Center of mass is a point. Center of mass is a point where entire mass is concentrated. Entire mass is concentrated. Entire mass is concentrated. Center of gravity is a point Center of gravity is a point with respect to the body. The point WRT means with you are right fully, of course, in the exam. WRT means with respect to the body, where weight of the body acts, where weight of the body acts, where weight of the body acts. Weight means mg, mass means m. That is first difference. Second difference, it depends only on mass. It depends only on mass. It depends on mass m and gravity g. Third, it is independent of g. It is independent of g. Center of mass independent of g. Center of gravity, it depends on g. Second, third point are one and the same almost. It depends on g. Is theory clear? Because I'm writing fast little bit. Depends only on mass. It depends on mass m and gravity g. So it is independent of g. It depends on g. Next point is fourth point. Center of mass may lie within or outside. Center of mass may lie inside or outside. Inside or outside the body. Inside or outside the body. And this example, ring is there, tenicoid. It lies outside. Center of mass may lie inside or outside. Here, center of gravity lies within the body. Center of gravity lies within the body. Within the body. So I am writing once again. Don't worry about this. Within the body. I think you understood these four differences, 4 marks. So generally, for smaller regular objects, common point. For smaller regular objects, center of mass and center of gravity will coincide. Center of mass and center of gravity coincide. General point this is. Center of gravity will coincide. When they will coincide? When small objects, like square plate, circular plate, like that. Center of gravity will coincide. This is general point, not difference. This is general common to both. Now I written differences. Please see, go to the differences. These 4 if you write, it is enough. So center of mass is mass. Center of gravity means weight. That's the only difference between the main difference is that one only. This is very, very important question for 4 marks. They're asking theory question only. So I am ending rotatory motion. If any extra questions, because board point of view, many times these questions are asked. Define angular momentum, state law of conservation of angular momentum with examples. Used to ask previously before 1918, 17 and all that. Just refer from question paper from 20 to 24. 4 years papers verify. So this is the rotatory motion. Next chapter I'm telling about gravitation. Next I'm telling about gravitation. In this one, 4 marks question will come. I'm telling about very, very, very important questions. 1 or 2 if I skip also, anything you represent for us will explain. So those who are aiming 60 out of 60 also, proper representation is there, because 4 marks question you have to answer only 6 out of 8. 6 out of 8. 6 theory questions will come, or 7 theory questions will come, 1 problem will come. 6 theory questions will come, or 7 theory questions will come, 1 problem will come. 6 theory question means 2 problems. 7 theory question means 1 problem. But choice is there. You are right 6 only. So gravitation chapter, I am explaining first question. This is very important. 1 question will come. State and explain Kepler's laws of motion. State and explain Kepler's laws of planetary motion. Kepler's laws of planetary motion. They are asking number of times this question. There are 3 laws are there. First, law of orbits. First one is called law of orbits. First one is called law of orbits. Every planet, so you know planets revolving around the sun. Students, you know, every planet, okay, revolves around the sun. Revolves around the sun in elliptical orbit. In elliptical, not circular orbit, elliptical orbit. Sun is at focus. Sun is at one of the foci. Sun is at one of the foci. Because ellipse will have focal points. If you want to draw a diagram, you draw from textbook. But if you write definition is enough. Every planet revolves around the sun in elliptical orbit. Sun is at one of the foci. This is called law of orbits. Second is called law of areas. Law of areas. Every planet sweeps equal areas. Sweeps equal areas. Equal areas in equal times. Equal areas in equal intervals of time or equal times. Every planet sweeps equal areas in equal aerial velocity is constant. Every planet sweeps equal areas in equal times. This leads to law of conservation of angular momentum. This leads to the extra point. This is star mark I am keeping. This leads to law of conservation of angular momentum. Law of conservation of angular momentum. Of angular momentum. Angular momentum means what? MVR. So it says that speed is not same everywhere. Speed is maximum at near point. Speed is less at farther point from sun. So every planet sweeps out equal areas in equal intervals of time, equal times. This leads to law of conservation of angular momentum. Last, law of periods. Law of periods. Law of periods. Square of the time period of revolution of planet. Square of the time period of revolution of planet. Time period of revolution of a planet is proportional to cube of mean distance from sun. Proportional to cube of mean distance from sun. Cube of mean distance from sun. Why you are taking mean distance? Because from sun they are not at equal distance. Square of time period of planet is because it is egg shape, elliptical shape. Circular means they will be at equal distance. So different distances are there from sun planet. When it is nearer to the sun, summer. Farther from sun, winter. Like that is there. So proportional cube of mean distance from sun. So time period is given by the letter t square is proportional to r cube. T square is proportional. This is the mathematical formula. What is t? Time period. Time taken to complete one revolution. Time period. R is mean distance. R is mean distance. Mean distance of planet from sun. Mean distance of planet from sun. It is also equal to R is also equal to semi-major axis. It is also equal to semi-major axis. There are major axis and minor axis. One is the large axis and this is called, this mean distance is also equal to semi-major axis. Semi-major axis is this one. This is called semi-major axis. This is called semi-major axis. So R will be equal to A and what? This is called semi-major axis. Sun will be somewhere here. This is sun. Planet. This is planet. Planet P1, planet P2 like this. This is a diagram. Semi-major axis will be like this. This is Kepler's laws. This is very, very important question. Now, I am doing define orbital velocity. Define orbital velocity. Define orbital velocity. Orbital velocity. Derive the expression for it. Derive the expression for it, derived expression for orbital velocity, derived expression for it, derived expression for it. What is orbital velocity? Here we will take circular only, except in Kepler's laws, everywhere we will take orbital velocity of satellite. Satellite is revolving around the planet. What is orbital velocity? Definition. Orbital velocity. Orbital velocity means velocity with which a satellite is kept in circular orbit, around the earth, any planet, but around the earth, mainly earth is there, around the earth. The velocity with which a satellite is kept in circular orbit around the earth is called orbital velocity. Orbital velocity. So I am drawing diagram. This is definition. Velocity with which satellite is kept in circular orbit around the earth is called orbital velocity. To derive orbital velocity, expression for orbital velocity, that is VO. I am drawing diagram. This is diagram. The smaller radius of the orbit is equal to capital R radius of the earth. Satellite is launched here with an orbital velocity V0, like this. Here m is mass of the earth. Satellite radius of the orbit is equal to capital R. Capital R is radius of the earth. This is a derivation. But there is centripetal force is there here. So derivation evolution start is centripetal force. Here you have to consider forces. Centripetal force is equal to gravitational force. Centripetal force is equal to gravitational force between earth and satellite. Centripetal force means, what is the formula for centripetal force? mv0 square by r. This is the expression for centripetal. R is the radius of the orbit, which is equal to capital R. Capital R is the radius of the earth. Centripetal force is equal to gravitational force. Gravitational force means G. Capital M is mass of the earth, small m is mass of satellite. Capital M small m by r square. Small m gets cancelled. That means not dependent on mass of satellite. R square gets cancelled. So V0 you are going to get. It implies that V0 is nothing but under root Gm by small r. If small r is equal to capital R, what is capital R? Radius of the earth. When revolving very close to satellite is revolving, one second. When I will draw diagram once again. This diagram, when you are drawing, you draw like this. This is the orbit. This is the earth. Actually. This is the earth. Earth radius is capital R. Small r is equal to capital R. This is the earth. This is the earth here. This is the orbit. Very close. Okay. Small r equal to capital R radius of the earth. Therefore, V0 will become under root. V0 will become what? Under root Gm by R. Small r equal to capital R. So, what is the value V0 you will get is nothing but 7.92, very large, kilometer per second. 7.92 kilometers per second, or approximately 8 kilometer per second. 8 kilometer per second with respect to Earth. This is expression for orbital velocity. A satellite is revolving in circular orbit around the Earth, very close to Earth. This is called earthbound satellite, surface satellite. So this is very, very important derivation. Now I am telling you, derive the expression for escape velocity. Define escape velocity. These two are, they are asking whichever question. Define escape velocity. Derive the expression for escape velocity. Escape velocity. Escaping means what? Escaping from the gravitational field of the earth. What is the definition here? Define escape velocity, derive the expression for escape velocity. What is escape velocity definition? The velocity with which a body is projected, velocity with which a body is projected, from surface of earth, so that it escapes from gravitational field of the earth, gravitational field of the earth. So it is escaping, it is not coming down. Let us say you project a rocket anywhere. For example, in Diwali time also, it come back in any house. But this velocity with which a body is projected from surface of the earth, that it escapes from gravitational field of the earth, is called escape velocity. Escaping from where? Escaping from the gravitational field. Friend, this word is clear or not? I am writing once again. Escape field. Yes. Escape velocity. Escape velocity is given by the letter VE. Now I am deriving the expression. How you derive? Nobody can separate a person from the surface of the earth, student, because you are bound to the earth. Any person, whoever a person may be, it is difficult. Object or person or anything, difficult to separate from the earth. You have to give such a very large velocity so that it goes beyond the gravitational attraction of the earth. So you derive the expression for escape velocity. To derive expression for escape velocity, to derive expression for escape velocity. Automatic. There is expression for escape velocity. So, friends, I am projecting a body with a velocity v here. You are taking center. What is the distance from center radius of the earth? M is the mass of the object. You are measuring distance from center of the earth. This is called center of the earth. Center C you can take, or O you can take, center of the earth. So what is the energy given? Kinetic energy of the body. Now you are do by not by forces. Remember, this derivation can be done by kinetic energy. Kinetic energy Ke is nothing but half mv square. Kinetic energy. Now I am writing binding energy or gravitational potential energy. Gravitational potential energy. What is this expression? Gravitational potential energy. I am writing gravitational potential energy. You think that it will be zero, but it won't be zero on the surface of the earth because you are taken from center. Minus binding energy means minus won't be there. Minus gmm by capital R. Gravitational potential energy is given by the formula minus gmm by R. When the body escapes, kinetic energy will be equal to magnitude of gravitational potential energy, or binding energy, gravitational potential energy. So kinetic energy is given by the formula half m. Whenever it escapes, you have to write escape velocity. When the body escapes, half mv e square is nothing but equal to g capital M small m by capital R. Small m gets cancelled. So you are going to get escape velocity square is nothing but 2gm by R, escape velocity square. Therefore, escape velocity will become under root 2gm by R. Escape velocity is nothing but under root 2gm by R. Orbital velocity is root gm by R, but we are getting escape velocity under root gm by R. What is escape velocity? 11.2 kilometer per second. Very large. Very, very large. 11.2 kilometers per second means. Aeroplanes also will have 360 kilometers per hour only, or 300 kilometers per hour. But kilometer per second this is. So that much velocity if you give, any body will escape. Not only body, any person, any heavy person, anybody will escape, independent of mass of the object. Escape velocity is 11.2 kilometers per second. And in the gravitation last question, Gravitation, last question is, what is geostationary satellite? What is, they are asking often this, what is geostationary satellite? What is geostationary satellite? What are its uses? This theoretical question. What are its uses? What is geostationary satellite? What are its uses? This satellite is launched from large height actually. What is geostationary satellite? Definition. The satellite which appears stationary when I'm writing, please see the writing, student. Stationary means rest. Which appears stationary. Satellite which appears stationary with respect to a person on earth and revolves with a time period 24 hours as that of the earth. As that of the earth time period. Earth time period and this time period is same. Main point you have to write this one, 24 hours. It rotates from, next point, it revolves from west to east. It revolves from west to east. From west to east. In the equatorial plane, from west to east in the equatorial plane. Radius of the orbit is very large. Radius of the orbit is very large, is equal to r plus radius of the earth plus h. H is height of satellite. H will be around, H is approximately equal to 6 times radius of the earth. H is nothing but, we go to very large heights. Height is measured from surface of the earth. So satellite which appears stationary. For a person it appears stationary in the earth. But it is revolving with time period 24 hours. Even though it is revolving, it appears stationary for a person on the earth. As that of the earth. It revolves from west to east. This radius of the orbit is called parking orbit. R is equal to r plus h. What are the uses now? I am writing uses. To find the size and shape of the earth. To find size and shape of earth. First use. To find mineral deposits in the earth. To find mineral deposits in earth. To find the mineral deposits in earth. Third, for telecommunications, for communications, satellites are used. For communications, these satellites are used. So Sriharikota and all that we are having, these satellites are used. For meteorological divisions, atmospheric, meteorological. For meteorological information. For meteorological means weather. Meteorological means weather forecasting. For meteorological information like weather forecasting. Weather forecast. We are using this geostation set to find size and shape of the earth, to find mineral deposits in the earth. For communications, these satellites are used. For telecommunications, for meteorological information, spelling you check, meteorological information, weather forecast, these geostation satellites are used. So what are the important questions? Kepler's laws, derivation of orbital velocity, derivation of escape velocity, satellite. Out of 4, which will come, we don't know. All are equally important, 30%. One time one they are asking. All 4 questions compulsory you have to read. Definitely one question will come. Right, student? This is regarding gravitation. ఏం చేద్దాం 20 minutes టైం చెప్పిన ఇంకో చాప్టర్ ఏమన్నా వద్దా షార్ట్ క్వశ్చన్స్ ఇంకా 2 చాప్టర్స్ ఉన్నాయి. మెకానికల్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్స్ ఒకటి, థర్మల్ ప్రాపర్టీస్ ఒకటి. దాంట్లో 3, దీంట్లో 3, 6 క్వశ్చన్లు ఉన్నాయి. ఒకటి చెప్పనా? ఏదైనా ఒకటి చెప్పనా? మెకానికల్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్స్ చెప్తాను. దాంట్లో 3 క్వశ్చన్లు ఉన్నాయి. ఒకటో రెండో అవుతాయి. మళ్ళీ కంటిన్యూ చేయాల్సి, రేపు కంప్లీట్ చేసేసి. ఓకే. ఓకే స్టూడెంట్స్, అయిపోయింది. పేస్ అయిపోయింది సార్, పేస్ అయిపోయిందా? చూడండి. సో నెక్స్ట్ చాప్టర్, మెకానికల్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్స్. మెకానికల్ ప్రాపర్టీస్ ఆఫ్ సాలిడ్స్, velocity. Mechanical properties of, one short question will come here. Mechanical properties of solids. What is the important question here? Stress, force by area, strain, change in length by original length, or change in volume by original volume. Hooke's law says that stress is proportional to strain. So Young's modulus is nothing but longitudinal stress by longitudinal strain. So first question, derive the expression for strain energy. Define strain energy. Define strain energy. Derive the expression for it. Derive the expression for it. Derive the expression for it. Define strain energy. What is strain energy? What is strain energy? I am writing strain energy. Strain energy. What is strain energy? Work done in extending a wire. Work done in extending a wire. Extending a wire, a steel wire or copper wire. Work done in extending a wire is stored as potential energy. Stored as potential energy. Work done in extending a wire is stored as potential energy called strain energy. Strain energy. Work done in extending a wire is stored as potential energy called strain energy. This is the definition for strain energy. I am writing now derivation. I am writing derivation. Derivation of strain energy. How I derive? Let small dW is small work. dW is small work. dW is small work in extending a wire by dl. dW is small work. dW is small work done in extending a wire by dl. But by dl small display. dl is small extension. dl is small extension. I will write dW is nothing but I am using some force. How to extend the wire? Or use the force FDL. FDL. This is first equation. dW. W is called work. dW is small work. FDL. How to find expression for F? By definition of Young's modulus, you will read definition of Young's modulus. Young's modulus is there in solids. Young's modulus Y is equal to F L. L is natural length. By extension, I am writing small l. What is small l? Extension. A is called area of cross section. What is L? Initial length. Small l is called what? Extension. Small l is called, here what is small l? extension. Generally we write E or delta L, but we are writing extension. From this, force can be written as Y is constant, Young's modulus. Y is Young's modulus. F is nothing but YLA by capital L. YLA by capital L. So this is by definition Young's modulus. This is second equation. This is second equation. Substitute in this. Then dW will become, instead of F you will write F L A by L dl. What is dW? Y L A by L into dl. What is Y? Young's modulus. What is A? Area of cross section. What is capital? Original length of the void. What is dl? Small extension. L is final extension. So I am doing integration now. What are constants? Integration dW, that is called energy. Integral dW, what is constants? Y A by L constant. Integral LDL, integral LDL, integral LDL, integral LDL, integral LDL, integral dW. Integral dW is called W Y A by L. Limits you have to apply. What is the limits? Of course, 0 to L you have to apply. 0 to L. YA by L. What is integral LDL? L square by 2. L square by 2 between the limits 0 to L. Again, answer will come as, because lower limit is 0, you will get it as YAL into L square by 2. I'll get L square by 2. YA by L. This is the answer actually. YA L square by 2 into L. L is called original length. But this will modify. This work done is called strain energy. This work is called strain energy. Young's modulus stress by strain you will write. What is Young's modulus? Stress by strain. Stress by strain. Therefore, stress by strain. If you write, work done will become, you will write work done. Wherever Young's modulus is there, you are writing stress by strain into area by length into L square by 2 here. Okay, students. My aim is, up to this, it is easy to understand only. But here onwards, you have to do modification, because I want to answer in terms of stress and strain into volume. For that, what I am doing is, stress. So half you bring here, half stress into, I am multiplying this with L, dividing by L. I am multiplying by L and dividing by L into L square. L square 2 I have brought here. Why I have got L square? Because I multiplied by L and divided by L. L already is there, L square. Why I am doing like this? Half stress. Okay, students. Area into length. Area into length is called volume. Area into length is called what? Volume. Into L by small l by capital whole square. Small l by capital whole square. Okay, students. Small l by capital. Small. ఒక్క నిమిషం లాస్ట్ ఒక్క నిమిషం తీసేద్దాం ఒక్క నిమిషం ఈ మధ్యలో ఆపలేం కదా ఒకటే 1 సెకండ్ అయిపోతుంది హియర్ సో వాల్యూమ్ వాట్ ఈజ్ వాల్యూమ్ ఏరియా ఇంటూ లెంగ్త్ సో ఓవర్ W is nothing but half stress into L by L is called strain. L by L is called strain. Here already strain is there. Here already strain is there. Here strain is there. Stress by strain. This is nothing but equal to stress by strain into volume V. This is nothing but strain square. L by L is nothing but strain. L by L is nothing but strain. This is nothing but strain. Extension by this is strain. Therefore, you are going to get W is nothing but equal to, when strain square gets cancelled, W is nothing but half stress into strain into volume. Stress into strain into volume. This is the derivation for strain energy. Okay, friends, thank you.